You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem. Good morning, good afternoon, and good evening, wherever you are. And we're coming to you from Boston, Massachusetts. Today is October 13th, 2023. I hope everyone is doing well and staying safe. Let's dive into it. Friday, October the 13th, that is. Hopefully your day is going pretty well. How you doing, Bhavin?
I'm doing good, man. Friday the 13th, I'm not as superstitious, so I'm doing good.
I'm usually not either, but the way my day has been going so far.
Yeah, you
hard
have
not
something
to
to blame for. Like, come on. It was because of October the 13th. Like,
I mean, between like my basement half flooding and
Mhm.
just
Yeah.
other stuff going on.
Not fun.
Not fun. Hopefully, you're doing some fun stuff this weekend. I don't know, maybe.
I don't
Finally,
know.
no rain.
Yeah, agreed. Like even though the temperature is like, not as much fun to be outside.
What?
But yeah,
This
put your
is like
sweater weather.
epic sweater weather. Yeah,
Yeah,
yeah. This is
sweater
fall
weather.
weather, man. This is perfect weather.
I know. I'm just debating whether I should make the trip to like White Mountains
Oh yeah.
for the fall thing, but then just looking at things on Instagram, like, man, it's so crowded, and I don't
So
really, yeah. So I might not end up doing that, but I'm still trying to figure out like if I should like wake up like super early, drive there, reach there at like 7 a.m., look at the colors in the perfect golden light, and then come back before the crowd show up.
yeah.
So if I
I've
yeah
seen pictures of like, are you talking about like the Kankamungus Highway?
yeah
It's right. Yeah, yeah, and it's just like bumper to bumper. I don't know. I feel like it would take all the fun out of it.
Yeah. Yep. So that's why I don't have any concrete plans. I was like, I'm just trying to convince myself that it's okay if you don't go. Like, you're still in New England. Like, they won't
Just
kick
look
you
out
out.
the window, but oh no, you're kind of in the city, so you gotta
Yeah.
get out here. So come visit me, and then you can see some trees.
Perfect. Nah. But yeah, no other plans, right? Just like full steam ahead for KubeCon, as you know, like both of us will be there,
Yeah.
representing our like employers, but also just trying to catch up with people in the community. So should be a fun time. But yeah, 3 weeks, man. Whew, cutting it too close.
Yeah, no, real close, and we're gonna be at DevOps Days Boston
I know.
Monday and
Yeah.
Tuesday. We'll be doing the show, sort of
Mhm.
pseudo live in the afternoons at DevOps Days Boston, which should be a lot of fun. So I don't know if anybody listening is going to be there, but come stop by. We'll have a little bit of swag,
Yeah.
stickers and stuff like that for you, and you could come talk to us about what you're up to and why you're there. That'd be fun.
I know. It sounds like a really cool event, right? Like I haven't been to any previous DevOps Days
Oh
Boston's.
no,
Like
okay, yeah.
I moved here during COVID, and like I think this is the first one after
Oh,
COVID.
that's right. Yeah, yeah, yeah.
Yeah. So,
I've been to them pre-COVID, like a long time ago. I think it's been
yeah.
going on since 2015 at least, because that's I want to say the time frame I was there. So
Okay. Yeah, and they have been posting on their LinkedIn channel, right, about like the different speakers and the different talks. I'm excited for those. Like I added a few people from the speaker list to my LinkedIn network, and those are some awesome people to follow. So I'm excited, dude. Hopefully, we get to have conversations with them. Again, this is mostly ad hoc, right? We'll see how it goes, but yeah, I'm excited for the event in general.
yeah, exactly. Paul Bruce does an awesome job with the organization and organizers in general. Thanks to all of them for putting it together, and we're
Yeah,
excited to be there. Cool. So
awesome.
we have a fun topic. It's just you and I today. We're going to jib a little bit about Kubernetes and specifically about sort of what its role is at the edge. But before we
Mhm.
dive into that topic, got a bit of news. So I think it's all your news articles. So let's dive in.
Yeah, let's do some cloud native news, right? So first and foremost, Cilium, the CNI plugin that everybody loves, officially graduates as a CNCF project. So
Mhm.
moves into that graduated status, joins the likes of like Flux, Argo, Kubernetes itself. Again, that just means it has a lot of community support, and the amount of money that Isovalent is putting in behind it, that says a lot as well. For people who don't know what Cilium is, it's a CNI plugin that provides layer 3 to 4 connectivity, 3 and 4 connectivity between container workloads. It has since expanded. I think it added like network policy support, some sort of meshing multiple Kubernetes networks together, and allowing for like ingress and egress gateways and so on and so forth. So obviously Cilium, I think it's a default offering if you select deploy like an AKS cluster and an EKS cluster.
Okay.
But this just shows to me like, okay,
Yeah,
this is a stable thing.
Yeah, they have some observability stuff in there as well, some security stuff.
Yeah.
And I'm reading here that it's the second most active CNCF project in terms of like commits and all that stuff. So that's
Oh wow. Okay, so I'm assuming first is Kubernetes.
I don't know. That's a good question.
Okay, awesome. And then a couple of funding rounds, right? Just a note, right? I think people are raising money. That's always a good sign, right? We want these Kubernetes startups or startups in the Kubernetes ecosystem to be around, like to start new ventures that solves challenges or be around and continue delivering value to users and customers in the community. So none of the startups are now sharing what their total valuation is, because some of these might be like flat rounds or down rounds. This is just new money that's making sure that people still have jobs and the technology continues to be there. So first vendor on the list, Pulumi. Everybody knows, everybody who's using anything or doing anything in the infrastructure as cloud space knows what who Pulumi is. They raised Series C, $41 million. And we had Scott Lowe from Pulumi last year at KubeCon on our podcast to talk about everything that they're doing. But an interesting stat, right, that they shared in their announcement or press release was they have like 2,000 customers that have chosen their Pulumi cloud offering for their infrastructure as code. So that's always a good number, right? Like you have, in addition to the 150K end users that are using your open source offerings, having like more than 2,000 paying customers is definitely a good sign. And with Terraform, the way things have evolved in the community, and with OpenTofu, I think Pulumi has the opportunity to become like the go-to infrastructure as code solution in this ecosystem. So, congrats to everybody at Pulumi. We're glad that you have some new money to spend.
Yeah, VC money is not an easy thing to come by in today's ecosystem, especially in sort of the infrastructure as code space where there's a ton going on. So yeah, absolutely.
Yep. And I think even like your VC money comment, right? I think it's really difficult for people to do these B, C, D, E, F rounds. I think if you are in that early like seed, maybe pre-seed, maybe Series A, I think you still have a good chance of raising money, because the valuations are more in your favor. For people who have raised money during the pandemic when the valuations were crazy high, the VCs don't want to invest more money at that high valuation. So you will see compromises being done when these next rounds show up. But talking about like seed funding rounds, perfect opportunity to call out a new startup called Perfect Scale.
Perfect opportunity. Did you do that on purpose?
Yeah, I did. I'm so proud of myself at this moment, right? Like, come on, yes. Like this is what episode 50 something does for you. You build sentences on the go. But yeah, Perfect Scale raised like a $7.1 million seed funding round. They did have some pre-seed funding, so basically their total capital raised is around $10 million. They want to. I love their mission, right? Their mission is to level the playing field for optimizing Kubernetes costs and performance.
Mm-hmm.
So basically turning every organization into an organization that has those elite DevOps and R&D teams to manage their Kubernetes clusters for them. So power to Perfect Scale. From their website, it looks like they have great dashboards where they can help you monitor and improve your application performance, resilience, some Q cost flavor. So they show you wasted cloud spend or the amount of money that you can be saving by changing some things. And then adding automation to reduce repetitive operations tasks. So again, pre-seed round, right? So they're still brand new. Their technology stack might not be like fully evolved, but it's another startup to watch out for in this ecosystem.
Yeah, I feel like in the last year, the space around optimization and automation, or even when you combine those things with sort of AI and ML models.
Oh yeah, you said the right word, like right buzzwords.
Those types of startups I think are probably at the top of the list when it comes to the ones getting funding and or the ones breaking into the market. I'd say I'd love to break that down a little bit more, but just by looking back at kind of all the conversations we've had, I would put money on it.
No, I think I don't have the stat in front of me, but I read some article from TechCrunch, which was like, if you have anything to do with AI, like true AI, like not just adding the word AI in your description or for what your company does, you have like I think 40% or 60% more chance of raising venture funding right now. So that's obviously a good sign. And as you said, anything to do in that ecosystem, yeah, you're good. So don't worry about not being able to grow your company or build your company from scratch.
Exciting stuff.
And then finally, Loft Labs. I don't know if people know Loft Labs, but yeah, they have an exciting solution called vCluster that has been around in the open source ecosystem since I think 2021, so around for 2 years. According to their website, it has been super popular with over 40 million virtual Kubernetes clusters already deployed using the vCluster project. So vCluster allows you to have like a multi-tenant large Kubernetes cluster, and then you can spin up these V clusters or virtual clusters in individual namespaces of that multi-tenant cluster. And each of these virtual clusters are fully CNCF conformant, have access to the same API. So if you wanted to run a multi-tenant stack where each user got their own Kubernetes cluster, or at least they felt like they got their own Kubernetes cluster, vCluster is the solution for you. The new announcement talks about vCluster.pro, which is their commercial edition now for the vCluster software. It adds additional admission security controls. So like provides an isolated control plane, has like a new core DNS pod, which basically combines like core DNS, API server, and Syncer components into a single pod and enable some networking between the virtual cluster and the host cluster, or between different virtual clusters that are running on the same host cluster. So again, vCluster is interesting. This is just a commercial solution for it.
Gotcha. Yeah, I think the whole concept of abstractions, right? This is a recurring theme, right? Abstraction on top of Kubernetes.
Yep.
Not surprising here, although I did read through this a little bit, and it does say sort of like today it's most widely used pre-production, meaning reducing the overall physical Kubernetes servers that you're paying for. Again, really tied to efficiency and cost and those kind of things. But I think the pro thing is more aimed at production anyway.
Yeah, and the pre-production thing makes total sense, right? Like you don't want all developers to continuously spin up Kubernetes clusters and have to pay cloud like costs on your cloud bill or on-prem. You need to scale and have that infrastructure because each Kubernetes cluster needs a control plane, a highly available control plane, even maybe 3 nodes for the testing that you want to do. So yeah, this definitely helps solve that pre-production use case where it accelerates the time with which developers can write code, test it out, and then eventually push things into a proper Kubernetes cluster that's running in production.
Yeah, and I feel like this is a topic we've kind of talked about a little bit in terms of the complexity of managing a lot of like a fleet of Kubernetes clusters. With our conversation with Maduri and Milodal, right? They're kind of being able to manage them all the same from a single endpoint. There's solutions out there for this kind of thing, but it's clearly high priority problem that needs a solution. So yeah, very interesting. I haven't heard about it until this.
Awesome, and that's it for the news section for me, Ryan.
That's it for the news section for me too, Bhavin.
Let's go.
We're keeping the news a little short to this week. It's Bhavin and I again. We don't have a guest today. We are going to be recording some stuff again next week at DevOps Days Boston, so we're kind of driving into next week. But today we did want to have sort of one of our high-level 101 episodes about sort of Kubernetes at the edge. We did a few interviews with some members of the community, both from MLB and last episode with Chick-fil-A, that really focus on these types of solutions. So we wanted to kind of take a step back, even though having those real use cases are super valuable to hear the insights from those individuals. We wanted to kind of step back and say, what problem is being solved? What does it mean? What are the projects out there that you could do this kind of thing? So I don't know, where do we start? Let's start with just defining a little bit about what is edge computing. Let's go.
Edge computing, right? Like I love that we have started using these terms. And again, edge computing is not like a brand new term that even Kubernetes came up with. It has been around, but I think for me, the crux of the solution or crux of this term is it's just enabling you to run or process data closer to where it's generated, rather than shipping everything back to like a central data center location or a central cloud location, which might result in like additional latency. So this is like going to the source. I know I'm going to butcher this up, but it's like what, taking the horse to the well to drink water instead of bringing the well over. I hope I said it right, but yeah, it's about like managing and manipulating your data and processing your data closer to where it's generated. And as Ryan already said, right, it's those examples like the Major League Baseball stadiums and the Chick-fil-A locations or any other retail locations that you might have. And like one more thing before I hand it over to you, Ryan, for your perspective. It's like this is also because even today, even with the amount of bandwidth that we have available, I know I have a gig internet at home, so obviously
You
commercial.
do?
Yeah, I
Lucky
do,
guy.
dude.
Lucky guy.
Even with all of these things, like the cheapest way to transfer data is actually through UPS or FedEx, right? And that's another reason why you see those big ass 18-wheeler trucks from AWS helping you to move your data from your on-prem data centers to your data centers. So this is like, okay, why do I need to push everything? Like I can just process my data, analyze it, and maybe send a summary back to my core data center. So this is us talking about everything that involves or falls under that bucket of processing data locally.
Yeah, absolutely. I mean, for me, I think edge is really defined by sort of the way we as sort of users or humans interact with and expect systems to work, right? In terms of like when we're on our phones, we expect our whatever we're interacting with to be sort of speedy.
Yep.
We want fast response times for whatever application we're working with. But from sort of the organizational side, we know, like you said, moving lots and lots of data that might be collected at the edge, whether that's in a manufacturing
Mm-hmm.
facility, at a farm, or in a hospital. Those various use cases. I'm sure we'll talk about them a little bit more.
Yep.
There's not the amount of time that needed to wait on sending everything back to a core data center and coming back to it. So really, I think, right, edge is really fueled by performance and
Mm-hmm.
cost, I think, in my eyes, in terms of like looking at the amount of data and the user experience, or I shouldn't say solely the user experience, really the experience of
Yeah.
sort of whatever that use case may be, right? It could be another system interacting with it.
No,
But
and like I like that you bring up performance because thinking about performance, right? As you said, you don't want to wait for the response time of sending all of that data, getting processed at your data center, and then shipping it back. Like imagine self-driving cars, right? Like they
yeah,
have to
great
process
example.
data and videos in real-time videos in sub millisecond, even
Yeah.
smaller than that, fraction of a millisecond maybe. If they're waiting for to analyze like a red light or a pedestrian, if they're sending all of that video files, that they're huge files, right? Because it has it, like I'm sure it's in a good resolution. It's not, I'm sure it's not 4K, but it's not like some old format which I can't remember right now. But they
VHS.
have to do that like near real time analysis, right? So having edge solutions definitely help with that.
Yeah, I mean, self-driving cars is definitely like a sort of a cornerstone
Yeah.
use case for edge. I mean, a cell phone technically is an edge device.
Yeah.
A car is obviously a big one. There's so many out there we can go
Yep.
into, but I do want to mention the couple of episodes that we did talk about, right? In
Yep.
MLB's case,
Mm-hmm.
right? Those are the stats being shown to you on screen, when a home run is hit, or
Yeah.
how fast a fastball is going, or those kind of things. Those things happen in real time as you're watching them, right? I
Yeah.
think the expectation for you to find out how fast a pitch was the next inning, which is like at least 20 minutes later, wouldn't be a great
Yeah.
experience, right? So again, sort of the demand for processing the data closest, right, in the stadium we're talking about, I think, was the example. And these aren't necessarily what everybody thinks about when they think edge. There's a lot of different sort of um, perspectives on edge,
Yeah.
right? And I think there's this good paper that I was reading on the
Mm-hmm.
Packet Pub, I should say. There's a couple different ones, but they kind of talked about the different breakdowns, right? There's sort of the cloud layer, which is like the
Mm-hmm.
core that we kind of think about every time we talk about cloud, AWS, GCP, Azure. Then there's sort of the near edge, which is like the cell towers, LTE networks, those
Yeah.
kind of things. Then you have sort of the far edge where you'll find a lot of like the infrastructure based, even Kubernetes clusters we'll talk about
Yeah.
today. And then I think a lot of people, when they think about edge, they're thinking this paper defines it as tiny edge, which I kind of like that term because
Nice.
it really puts in perspective of like things are tiny, right? Like physically at
Yeah.
the edge, like these are sensors on farm equipment, sensors and an EKG or whatever it may be, that are collecting little tiny bits of data in a little small computing device. I think that's the most common, and maybe I'm wrong, but that's the most common when people think about like the IoT devices and edge. They associate those things, but there's so many levels of necessarily what someone's talking about edge, right? And there's even terms that have been used before this. I mean, with our conversation with Chick-fil-A, we talked about fog computing, right? Which one I wasn't necessarily super familiar with, but it more it kind of like think about a cloud that kind of encapsulates a lot of those different edge layers. So yeah, for the purposes of sort of those use cases, I think they vary, the MLB one and the Chick-fil-A one, because Chick-fil-A's, I guess you'd classify as retail, right?
Yeah.
I guess that would be, and really that's about sort of the experience of the customer mostly, right? I mean, I think we talked about how the stuff that the business cares about is what they're sending back to the core data center anyway, right? Some of it's just processed and used right away at the retail location. Same thing with MLB, right? The stuff that's surfaced right away, and then it's kind of tracked back. So we'll talk about the different types of data and data management later in the episode.
And I agree, right? Like the different protocols comment that you made earlier, like solutions or protocols like MQTT being relevant at those tiny devices or tiny edge solutions. It's and this was something that like Brian last week brought it up as well. Like there are air fryers or just regular fryers at Chick-fil-A locations that will send data to their edge location or their edge deployment in MQTT format. But I'm clearly not an MQTT expert. So for this discussion, for me at least, it's mostly like, okay, how does Kubernetes and its variants, like different solutions that are projects that we'll talk about today, fit into those use cases? Like, so I'm more worried about where the servers or the nooks that we have at these edge locations and how we orchestrate them and run our applications at that location. Then I personally am at like how we manipulate those tiny devices, because they are definitely important, right? Like all these edge use cases, they are the ones that are collecting and generating a lot of data. I remember like at when you used to work at Portworx, you did a cool demo around like a temperature sensor inside your office space and how it fluctuates and send all of that. So yeah, all of those, that's where the data is being generated. So our solution is like, okay, let's figure out how we process that data or how we make sense of that data closer to that edge rather than sending all of that information back. So agreed.
Yeah, that was a fun little use case, right? It was like the whole goal was to predict the temperature of my office, right? Eventually to run predictions on it, which was really not so useful because with a
smart
thermostat in my
thermostat,
house, you could pretty much guess what the temperature based on what. But it was interesting because you could see like different times of the day or year, that kind of thing, and that's a good use case because it's like, for this episode, we're going to talk about the Kubernetes components and where and how they run. We're not necessarily talking about every single edge use case. And, we talked about tiny devices. It's not always a tiny device. It could be a full rack nearer to, nearer to whatever application it's serving. Doesn't have to be those kind of things. So we're going to talk a little bit about sort of what are the projects out there, and in the Kubernetes space specifically. The edge is such a giant topic, but we'll focus in on them. Before we do that, I do want to talk about some of the challenges, though.
Yes.
Yeah.
Let's go. Yeah. Okay. So I think my challenge is like I know we have a bunch in this list, but for me it is around physical constraints. Like
Sure.
Edge locations are not your a tangent. So when I was doing my master's at NC State, right, they had a data center tour, and that was the first time I stepped foot in a data center, and it was
Okay.
so
Yeah.
fancy,
Very
dude.
cool.
Like it was like they had like the hot aisle, cold aisle,
Yeah.
everything was properly ventilated. They had to maintain temperatures. Everything
Yeah.
was so neatly wired up. I'm pretty sure it was like an EBC data center.
Okay.
Like I've personally worked in a proper data center as well, and it's not as neat. It's not as great. But like at edge locations, right, you can't expect to meet all of those same requirements. You won't even have like a
Sure.
proper rack. You might
Yeah.
just have like a Home Depot table or an IKEA table,
Yeah.
where you're just putting down your server and just putting a switch on top of it and making sure that it works. So
Yeah, I
I
think
think,
Brian said their Nooks in Chick-fil-A were just like the back office,
yeah,
or at
yeah.
least at one time, right? I don't know what it looks like today, but
Yeah, and that's a valid concern or challenge to solve for. So like in my past, right, I've worked at Lenovo, and Lenovo did like come up with like a really awesome, like a small x86 based server. I
Mhm.
forgot what it was called, the model number, but it was a completely ruggedized system. It was dust
Sure.
resistant,
Yeah.
moisture resistant, and still had like an Intel CPU under it, so you can actually run proper workloads on it. So I think it's, when you are thinking about the edge, don't think about Chick-fil-A's. Maybe even think about oil rigs, right, where you might
Yeah.
have, it's middle of the ocean, so you don't even know whether you'll have proper electricity coming. Obviously there will be, but like you have to plan for all of those things. So I think that's a big challenge to solve for, like how do we handle those physical elements when we are thinking just about technology.
Yeah. Or you know what, the use case that comes up that always makes me giggle a little bit is our friend and colleague Tim.
Oh yeah.
When he sort of wrote a paper on how he designed this bear-proof box because of the location he lives at on the top of a mountain, because
Hmm.
he's a mountain man in many regards. But basically, to help kind of maintain his network and connectivity for when things are off grid and those
Yep.
kind of things. But the whole idea was it was kind of baked into this bear-proof box because it was outside and those kind of things.
Hmm.
So yeah, Edge can really serve so many use cases. Challenges wise, I mean, the other thing is Edge, comes with complexity of the fact that there's just more locations,
Yeah.
right? When you're moving things, parts of the application closer to the data, and where it needs to be processed, you therefore have more locations you're putting this in, right? Even in Brian's use case, right, 3,000 stores, or MLB was
Yep.
hundreds of stadiums,
Hmm.
and you're not going to have personnel at those locations all the time,
Yep.
right? You need to manage these things sort of remotely. You may send field engineers, but that's a whole nother aspect to it. So that definitely adds to the complexity, right,
Yeah.
for the challenges on Edge as well.
No, I agree, right? Like it has to be about non like unattended installs and unattended management. Figure out how much you can do remotely. Like I remember like working with a grocery chain as a customer, as at a previous job, and to run all of their checkout systems, they installed like a half a rack unit, and that was their edge solution, right? Like that's what the scale of edge looked like. And it was important because they couldn't send all of that data from each point of sale system and the self checkout counters back to their core data center, which might be in a completely different region.
Mhm.
uh, to because that would just lead to like bad customer experience, huge lines at the checkout counters. They eliminated all of that by processing everything locally. So yeah, and no, they didn't have like an IT admin on
Sure.
staff
Yeah.
to manage all of that equipment. So it was all about like how can people from their main office manipulate or manage all of these half rack or server instances. How can they figure out like, okay, if there is any application failure, if there is any physical drive failure, node failure, how do you plan for these things, right? So I think
Mhm.
those are the challenges that you have to solve for when you're thinking about edge locations.
Cool. Any other challenges before we go to the next thing?
No, I think that's it. Like those are enough challenges, Ryan, I
Yeah.
think.
There's many more I'm sure we didn't mention, but that's
Yeah.
totally fine. Let's switch gears to talk about sort of, can Kubernetes help at the edge? Let's talk about some of our opinions in this matter.
Yeah. So I think Kubernetes can definitely help. Like, okay, if you expected a different answer listening to a Kubernetes Bytes podcast, come on, guys.
I mean, we
Kubernetes.
have knocked Kubernetes before. So.
Yeah, but I'm not going to say Kubernetes is useless. No, Kubernetes can definitely help you with these edge deployments, right? And for me, I think I was listening just for prep for this podcast episode, right? I was listening to one of the sessions that or webinars that one of our friends, Michael Cade, did.
Sure.
It was a panel discussion where they were talking about a similar topic. And the thing that popped out to me was, yes, Kubernetes is great, but it's not just Kubernetes, right? It is the standardization that it drives at all of these thousands or hundreds of thousands of edge locations that an organization might have. So it's not it's more about the API server and how it allows you to use declarative state of for management, or allows you to have that consistent API set to interact with it, then having actual Kubernetes at these edge locations. So it's about the standardization. Imagine having 10,000 retail locations for Target, right? And even if you are able to manage them perfectly, even if you have, like, let's say 10% of those locations having Snowflake deployments, it becomes a real pain in the ass to manage all of that. It becomes an operational nightmare. So yeah, I think standardization is the key for me. Like, that's where Kubernetes can really help you with these edge locations.
Yeah, and we've obviously talked about how Kubernetes isn't always just the thing you throw at a problem because it's there. You definitely have to take into account is do those APIs, do the orchestration components, does the sort of distributed system help you really accomplish what you're getting at? And you mentioned standardization, and I always come back to sort of containerization as just a topic in general, right? Because Kubernetes takes advantage of containerization,
Yep.
right? We're managing many containers and orchestrating many containers, and really the benefits there are the benefits that we're talking about when it comes to smaller runtimes. The general standardization of how applications are built and distributed, all these things we talked about in early days of sort of Docker and containerization, you definitely get those from managing many edge locations.
Yep.
I think we can't overlook those, and just because we're talking about Kubernetes.
No, agreed, right? Like the ability to package everything up in that container, in that I don't know, manageable unit for your application definitely helps. Agreed.
Yeah, and I'm curious about some other topics that I didn't look into for this episode, but I know we talked about WASM, cloud native WASM, and what its role will be. Again, really focusing in on sort of performance and form factor, smaller applications. I could see it be playing a pretty big role in Edge as well. I know we've talked about its use case in Edge a little bit, although it's definitely a newer sort of approach to application development. But I'm curious at how that kind of goes across, and maybe we'll sync back up with Nigel again to talk to him about the edge comparison.
Gotcha. And Ryan, I know, like, I spoke about like the server form factors, right? But I know, like, you wanted to talk about x86 versus ARM. Like, how does that play into edge locations?
Yeah, so if you're looking into edge deployments or just edge architecture in general, no doubt about it, you'll come across the usefulness of ARM processors compared to x86. And I'm not an ARM expert here, but basically
you have two of those. Come on.
Sorry. 1, 2, expert. Yeah. But really, ARM is sort of a solution that allows for less energy consumption and less power to generally less power to be used, which means that it also can run without fans a lot of the time. So a lot of x86 servers have the built-in fans and those kind of things to keep it cool. You talked about hot and cold aisles and data centers. You don't always have hot and cold aisles in a back office in a retail location. So ARM definitely allows you to run things, albeit has a lot of times less processing power, but it also means it's it doesn't get as hot, so you don't have to kind of worry about that as much
Yeah.
in terms of that brings the form factor down. That being said, some of the biggest supercomputers are built from ARM. It's not that it can't compete with x86, but it is used a lot more
Yeah.
in sort of the edge use cases, and it's unavoidable. I think when it comes to looking at form factor and how you'll design your compute when thinking about edge devices, because you'll be able to kind of think about how small those sensors and those kind of things are.
Yeah. And agreed, right? Like it's not that ARM can't be run in data centers. It's the ability for it to go down in form factor or support that no fan use case, right? Like so I think that's where it shines in specifically for these edge deployments.
Yeah, and the big thing I think, the big difference that I got out of looking at x86 versus ARM, right? x86 has all these, graphics cards and memory and storage and CPU as independent modules, basically.
Hmm.
Whereas ARM doesn't have a separate CPU. Instead, it's kind of part of the processing unit, the same physical substrate. So they often talk about these processors as a system on a chip or an
Yeah.
SoC. So again, that brings the form factor down. It also means they're designed by more manufacturers, and they're
Yeah.
designed more purpose built for the use case and solution, right? You talked about self-driving cars and things like that. Those are all going to be very purpose built systems, and I don't know the breakdown of how many or if they use ARM or not, but it just kind of leads to the point of ARM is going to be here to stay when it comes to edge.
Yeah. Makes sense.
Cool.
Okay.
So let's turn to let's just list a couple of the options in the Kubernetes ecosystem when it comes to sort of um, architectures,
Hmm.
or I guess I'll call them more platforms or distributions.
Distributions.
So
Yeah.
we have K3S, which
Hmm.
is well, we'll get into the details, but K3S is out there, which is kind of a smaller form factor of Kubernetes. We'll go into the details about that. Microkates, um, again, also sort of a Kubernetes distribution that's a smaller form factor, built for these types of use cases.
Hmm.
And we'll also talk about Cube Edge, which is sort of a bigger concept
Yeah.
of how you manage both sort of the core and the edge components. And then some other ones in CNCF landscape: Super Edge, Akri, I might not even be saying that right, AKRI, and OpenYurt, I think, is the ones I have on here that we'll kind of dig into a little bit. So let's start with K3S. Let's dive in a little bit.
Yeah, so K3S, right? Like if you do a quick Google search, Kubernetes at the edge or Kubernetes small form factor, the first result I'm sure that shows up is K3S. So K3S, there is a fun story which I learned this week, right? As I was doing research, like it was Darren Shepard, like he created this specific distribution at Rancher, and the whole reason for that was he was writing code, and every time he wanted to test something, he had to deploy like a full-fledged Kubernetes cluster, which took time, which took a lot of resources, and he's like, no, there has to be an easy way. And I'm just like, wow, when I have a problem, I just wait it out. I don't go and create a distribution, because Rancher, like Darren at Rancher, made this K3S distribution by removing over 3 billion lines of code, dude. 3 billion lines of code from the Kubernetes source code. He trimmed out all the non-CSI storage provider, any alpha features, any legacy components that weren't necessary to implement the Kubernetes API functionality or API fully. Like everything was gone. And then like he created his like small footprint offering or a distribution that he could use for his testing. And then it has just taken off from that point.
Yeah, I think the binary is what, like less than 70 megabytes,
I
right?
know.
Which is pretty tiny when you compare it to a lot of other things. I mean, I think the website also says less than 100, but I think it
Yeah.
depends on the version and things like that. But again, K3S is also supported on, I think, ARM64 and ARM v7.
Hmm.
So again, sort of a small distro, but also optimized for those specific architectures. Doesn't mean you can't run it on a big old x86 server
Yeah.
in cloud. You can absolutely do that, which is kind of maybe a pro for the flexibility of K3S. Definitely.
And like even though it removed all of those things that I just listed before, right? It is completely bare bones, but it still has all the necessary components that you would need to like run a Kubernetes cluster.
Right.
I
So
don't know
you
if I
have,
can say,
yeah,
I
you have
can
two
say.
two main components, right? It's the server and the agent in K3S.
Yeah, and
Pretty
it still
much.
has container D support, ingress controller. It has a CNI that you can use. So it has those things available inside the 70 megs of binary that it has that you can use to deploy. The only thing is it doesn't rely like on HCD for that backing data store. So
Mhm.
it uses it can use SQLite, and I know recently Rancher has also introduced like DQ-Lite or CRAFT or Craft, but I don't want to confuse the Kafka folks. So CRAFT to be used as the backing data store. So obviously you can take this and customize this if you want to install like a specific plugin for a specific storage solution that you're using at the edge. You can definitely do that. But yeah, bare bones, I think that's the keyword for me.
Yeah, and I think it's, some of the pros I had on my list for K3S was it can run in a single master sort of deployment, right
Mm-hmm.
for those really resource constraint. You have like a single master and an agent at a minimum, and it uses the built-in data store instead of etcd for that. But
Yeah.
it does have the capability to run HA, meaning it
Yep.
can run three masters, and then I think it plugs into other data stores. I think it was like MySQL and others, and some
Yeah.
other options, but gives you the ability to recover from certain failures of the master nodes and those kind of things. So it is flexible in the sense that kind of can run how you want it to, depending
Mm-hmm.
on the use case you have for it.
No, agreed. That's it for me for K3S. Like that's the information that I have. Like we can definitely like do a full-on episode and talk about all the different architectural components. But yeah, this is that one inch deep, mile wide
Yeah,
uh,
absolutely. The,
episode, right?
the only thing I'll add there is, whenever you have a technology that's backed by a bigger company like SUSE Rancher,
Yeah.
I think that gives you a little bit of support,
Mm-hmm.
right, for using the technology. So that combined with sort of the range of operating systems it can run on, I think has a lot of things going for it. It's probably, if not the most popular out there. I think the only thing I had on my cons list really that came to mind is it's just the Kubernetes distro. So it's not really going to solve other edge problems like how do you
Mm-hmm.
sync data back to the core, how do you manage
Yeah.
multiple K3S clusters, those kind of things. It is just kind of focused not on the full platform, but just the distro itself. Cool. We'll put a link into sort of more information about K3S and some of the architecture and stuff like that. But let's move on to microkates.
Yeah, microkates. I know this is, as you said, right? Like it's important that there is somebody backing the project, even
Yep.
though these are part of the ecosystem. Microkates backed by Canonical, so like you have a huge brand name behind it. I think the thing that differentiates this from K3S for me is the ability to run across Linux, Windows, Mac OS systems. So you can run like okay, the default way to run this backed by Canonical is on Ubuntu, but you can still run it on your MacBook Pro. You can still run it on your Windows machine or any other Linux distribution, and you can get access to like a Kubernetes compatible API set that you can work with.
I think it mostly runs as a virtualized Ubuntu flavor, though.
Yeah.
So it's not like it's natively running on Windows or anything like that, as far as I remember. So it does definitely lean towards the Ubuntu experience, meaning like
Hmm.
installation's easiest with Snapd, sort of their package
Yep.
manager and those kind of things. One of the things I really like about microkates is it starts as that really small form factor. I think they talk about at minimum needs 500 something meg of memory to run, by default, which is pretty small. It's not
Yep.
like the smallest thing ever, but it's pretty small. But they have this idea of add-ons,
Hmm.
right? Where if you needed a DNS component or a CNS component or a storage component, you can kind of add on this piece depending on how you're using it. So it can grow definitely
Yeah.
bigger than just sort of that embedded IoT sort of use case as well.
Hmm. And I think just a couple of things that uh, to add, right? Uh, with K3S, if you are running it on a 3 node cluster, you have to say that okay, please deploy it in a highly available fashion. For microkates, one thing that they have changed is if you add 3 nodes, it automatically knows that it has to do high availability or it has to figure out high availability. So it's by default versus manually enabling it. And then because it's using the Snap ecosystem through Canonical, right? It has automatic updates. So like the package itself gets upgraded if you have the set the right policy. So you don't have to worry about figuring out the right packages and maybe plan for upgrading your systems at all of these edge locations. If you set it correctly, it will automatically update the binaries.
Yep. Again, I think microcates work both with ARM and Intel
Yep.
as well. So definitely kind of tailored towards the edge use case. One of the things I did like that I pointed out in my notes here is that they provide a CIS hardening add-on.
Oh
So
yeah.
if you're very security conscious at the edge, which I imagine most are,
Yep.
you can kind of enable this CIS hardening add-on, which basically will kind of probe the environment and use those CIS standards to give you that capability of having that assurance that you're kind of meeting those requirements as well.
Okay. Let's move on to the next one.
Sure. All right. So the next one we have on our list is Cube Edge.
KubeEdge. So KubeEdge, again, I'm just talking about like, okay, all of these are smaller solutions, right? So the thing that I really liked when looking into KubeEdge is the high performance. Like they did some comparisons, some IO performance and some application performance. And out of the three solutions that we have discussed so far, like KubeEdge performs the most for some reason, like especially like for the blog that they did, right? So
If you were to
obviously
trust that one,
yeah. So with performance testing, Ryan, I know you and I both have experience. Like, okay, you have to set the right expectations, set the right
Yep.
parameters, and you can typically find a solution or a scenario where your solution stands out on top. But again, they do say that, okay, low resource footprint requirements, but with a higher performance to allow you to run a Kubernetes solution at your edge locations.
Yeah, and just because we were talking about microcates using 500 something megabytes of
Yeah.
memory to run, by comparison, the Edge sort of runtime for KubeEdge uses
Mm-hmm.
70 megabytes, or requires 70 megabytes to run, which is a fraction really when you're thinking about this, and I think there's a big difference that I see in KubeEdge is that it's not just the the control plane and
Yeah.
the runtime. It's a whole slew of components. If you
Mm-hmm.
dive into KubeEdge, right, there's cloud components, which they talk about Cloud Hub, Edge Controller, Device Controller, which run more in your cloud core. So the core data center that's kind of
Yep.
connecting to your edge endpoints. And then you have a whole bunch of edge components, which is Edge Hub, Edged, which is really the agent I was talking about, using that much memory to run
Mm-hmm.
those applications on those devices. Manager, Event Bus. We talked about MQTT before. Event Bus allows clients to connect through MQTT. That's more used in kind of the PubSub IoT framework. So really allowing you to kind of have the flexibility of using existing devices that might use those protocols. Service Bus, Device Twin, being able to visualize all the devices in your edge network. That it may know about. So Device Twin just kind of is a representation of what's on your edge network, even if they're not connected all the time.
Yep.
And mappers, which kind of allow you to kind of tie in other common IoT protocols like Modbus, OPC UA, and Bluetooth, which we all know. So lots of components. If you're just kind of coming from the, hey, I'm looking into K3S for Edge, and then you come to KubeEdge, it's a little overwhelming.
Yeah,
Honestly.
it's like, wow. Just your architecture diagram that we link,
Yeah.
like, okay, so many boxes, dude.
But in a good way, right? It makes
Yeah.
it really flexible. It also ties in that major component of, how do you sync certain information
Yeah.
from your edge to your core, which the previous two we talked about don't really tackle that, right?
Mm-hmm.
Whereas Edge Hub and Control and Cloud Hub are able to talk to each other to kind of get a viewpoint and sync certain information from your edge devices all the way up to
Yeah.
your cloud core. So there's a whole lot going on there. I think it's probably a great place to start for the full solution when it comes to thinking about how an edge architecture looks like,
Mm-hmm.
and having the necessary projects and those kind of things to get started. That being said, it is fairly new. How old is this project? I forget. I was looking at their documentation. The only reason I'm saying this because even some of their documentation is like coming soon, right? So it
Yeah.
doesn't even have the
And
pages.
again, it's an incubating project, right? So
Yeah.
it's not like any close to graduated, but it's not even like a sandbox project from CNCF. So it's still in the incubating phase, early phases. So if you want to change directions, you can definitely do that right now.
Yeah, exactly. So lots of really good stuff to integrate in the Cube
Mhm.
Edge project. I think that's definitely one of the benefits I had on here is that it's more than just a distribution.
Yeah.
Right, it handles all those things and supports the various protocols and those kind of things. That being said, I've never used it myself, but we'll put some links to the documents and things like
Mhm.
that on there as well.
Okay.
So
No, I think we spoke a lot, right? Like these are the three main projects. I know there are solutions from like Red Hat and how they do like 3 node clusters, including control plane and worker nodes. They do like something based on microshift, which is a space I think we should check out because they just spoke about it in the
right.
product update webinar yesterday. So that's definitely coming to GA status soon. It's and the ability to run like remote worker nodes. So your control plane can still run at your core data center. You just have remote worker nodes. So Red Hat has some interesting solutions. If you are in that OpenShift ecosystem, you can definitely check those out.
Cool. So, we mentioned some other ones. We won't dive into all of them in this episode.
Yeah.
Accree, OpenYurt, Super Edge. We'll put links to those in there. All other sort of CNCF projects that focus on sort of enabling sort of edge use cases, things like that. But let's go into a little bit about the sort of let's talk about data because that's always one that I think comes up a lot. Is when people talk about moving their applications to the edge, they often say, well, their data's going to the edge. That's
Yeah.
not true, right? That's not true. I mean, even in the most basic sort of forms, right? We're talking about, yes, there's a lot of data at the edge, but again, the point is to process that data as quickly as possible and
Mhm.
then reduce that to the value, right?
Yeah.
And that value is the thing that's fed back into other systems and or the thing that might be synced back up for analytics or their statistics or those kind of things.
Yep.
Yes, there you do have the opportunity to run data stores, right? We talked with, like I said, with Brian at Chick-fil-A. They had mentioned they were using Postgres at the
And
edge, but
MongoDB. Yeah.
in MongoDB, and the point there was that it's a database. Yes, you can use it just as any other Postgres, but the persistence, the expectations around persistence isn't really expected beyond minutes, I think,
Yeah.
right? Because you can use it that way, but the goal isn't to kind of have long-term storage of the data that's being used
Yeah.
in there.
Yeah, agreed, right? Like you don't have to store everything for eternity at those edge locations, but you need to collect everything, analyze it, ship the relevant information back to your central cloud locations, and yeah, and then keep doing this in a loop, I guess. So yeah, I agree. Like persistence is a thing that people need to solve for, but long-term persistence, maybe not.
Maybe not. All right. Before we wrap up, let's get into a couple of the use cases,
Yeah.
right? Why don't you kick us off?
Yeah, I know we spoke about like retail, definitely a big use case, oil rigs, cruise ships, like all of these are definite, like the I don't want to use the term. I remember I heard this sometime from a colleague. Heavy edge, like these are definitely scenarios where you have that half rack, full rack solutions,
Mhm.
which you can use to run a lot of applications and a lot of compute power. But then the self driving cars, the retail locations, the grocery chains, all of these things, I think that definitely helps. I know you wanted to talk about like a couple more around use cases as well.
Yeah, I think the ones that always get me, I don't know why they get me excited. It's like the farming equipment, like
Yeah.
the state of the art farming sensor edge type use cases where right they're picking up how much rain has been happening or like the nutrients or like some crazy
Yeah.
types of data that's being processed and therefore can feed back into directly into how that parcel of land or the crop is being kind of maintained. And those use cases are really exciting because they kind of tie this physical world
Yeah.
with the technological world. And again, those sensors are really providing feedback that needs to be sort of directly fed back into some of these pieces of equipment that can adjust on the fly, right?
Yeah. Like
You
based
don't.
on the moisture level in the soil, turn on the sprinklers, or based on like I know you like to talk about drones, right? So like fly a drone over your
Sure.
farm
Yeah.
and then figure out okay what needs care and what needs to more care, and you can figure it out or make decisions based on all of that data that you're generating.
Yeah, like the thermal and multispectral cameras that can feed data
Oh,
back
yeah.
into exactly the health of the crop, if it's
Mhm.
disease, those kind of things. Really crazy things that we don't know nearly enough about, but
Yes.
those
There's a
use cases are
there's a
are
whole
pretty
domain, right?
exciting.
Like ag tech or agricultural tech. That's like, yeah, you can go. I'm a big fan of TechCrunch and all
Yeah.
of their articles, and yeah, so they have like a whole section around ag tech and what companies are doing there.
Yeah, I mean, and then you could think about like finance and banking, right?
Yeah.
Your phone is technically an edge device for banking,
Yes.
to ATMs, and even just the probably something everybody does is streaming, from their Apple TV or
I know.
Roku or something like that. Those are edge devices that
Yeah.
need sort of um, that speedy response. We don't want to wait forever to start watching our shows because
Okay.
that's important. Anyway, lots of use cases. Let's end with where to get started.
Yeah, like I would just say, like, start experimenting with the projects that we discussed on this episode, right? Like, if you find anything that's interesting and you want us to do like a detailed episode, we can definitely do that. We can bring in experts from the community. Maybe we can get Darren to talk about K3S. So we can definitely do that. But yeah, we'll have a ton of links in the show notes where you can find more information about all these projects, maybe some use cases that you can use or use to, like, I don't know, start thinking about things. So
Yeah, I mean, one place I think I would suggest you get started is go grab a Raspberry Pi
oh yeah.
and go on Amazon and find some cool sensors that plug right into that Raspberry Pi, that can do some basic measurements or calculations, and you can start to process, and kind of write applications that process the data locally. You can also spin something up on AWS that you can send some data back to visualize or even do
Hmm.
processing, like the example we talked about before. I think that's a fun way to tinker if you're
Yeah.
into that kind of thing. Definitely go check that out. And obviously, the projects we listed are all a good place to start.
Awesome. That's it. Let's wrap this up.
All right. So again, we'll be at DevOps Days Boston next week. So if you are there, come say hi.
Hmm.
Well, shout out to joining our Slack, which there's an
Yes.
easier way to get there now. You can head over to KubernetesBytes.com. We finally bit the bullet and created a
I
proper
know.
website.
Let's go.
You can listen to all of our episodes there. You can watch all of our episodes there. You don't have to
Yeah.
go find them on wherever you may find them or YouTube. You can just go to KubernetesBytes.com, find out where to get our Slack, watch our videos and episodes there. Go check that out. And yeah, I think that's about it. And if you're at KubeCon, also we'll be there. So come check this out. And I think that brings us to the end of today's episode. I'm Ryan,
I'm Bhavin.
and thanks for joining another episode of Kubernetes Bytes.
Thank you for listening to the Kubernetes Bytes podcast.